Bonjour, mon nom est David Smith et je ne parle que très peu français. Je vais donc continuer en anglais et merci pour votre compréhension. So, thank you very much. I've been at Anaplan about 4 years and a lot has changed in that time. Primarily the size of our customers and the size of our data and the complexity of the models we've been dealing with. When I started, a 1 gigabyte model was unheard of, whereas now we're talking about 20, 30, 40, 50, 60, etc. But the engine itself hasn't really fundamentally changed. So the techniques and the structures and the formulas that we used 4 years ago are not really necessarily relevant now with the size of data that we're talking about. So as part of my role within the company in the last year, I've been looking very much at how we can come up with some best practices to try and address some of these issues that we see. So I've come up with an acronym, and as you'll see in the presentation, I like my acronyms, but what we want to try and do is to define the standard of modelling for all of you model builders out there that really looks at the main 5 elements here, that we look at the best performing structures, that we try and make our models more logical and the way that we build more logical, that we can understand what's there. Most of our models that we see when we go in to do reviews, and you probably got some yourself where you inherit them from your colleagues, it's all just a big mess of numbers backwards and forwards. And Anaplan allows you to do that. It doesn't tell you that that's the wrong way to do it. So we're trying to make sure that you can actually turn that round and understand what you've got, understand how the formulas are. And also we see a lot of people who do the same things over again and have unnecessary structures and formulas in the model. So again, we're trying to make sure that we give you the tools and the techniques and the tips to make sure you don't do that. And finally, I used to run a planning system about 15 years ago, and I was a model administrator. So everything I try to do as a solution architect is to make sure that I deal with how do you deal with a year-end rollover? What happens if I add another cost center or another account? To make it as easy as possible. Too often we build our models based on now and we don't think about the future. So again, trying to build techniques that are flexible, that allow the change that we inevitably will have within our models. And it is a bit of a compromise because you have to look at performance, usability and sustainability, and you can't ever get one perfect place. So what we look to try to do with these standards is to say, well, okay, if you want a good performing model, you may have to sacrifice some of that performance to get good usability, but also you don't want a really user-friendly model that performs really badly. So we have to try and balance all of those between it. And one of the first things that we've come up with is actually a structure and a methodology for how you build your models in terms of the modules design itself. And I've christened it DISCO because it's easy to remember, and actually it fits with how the models in Anaplan should really work. So going through the alphabet effectively, the D stands for your data. So this is where your models start. Inevitably, your models will have something as a source data, whether it's opportunities, whether it's employee information, whether it's transactions. You're going to have some data that comes in from somewhere. And you should really have a module or modules that contain that. And that really is all they should have. They shouldn't have anything else. You may build those in a way that allows you to transactionalize it to minimize the sparsity. Or you might have those in a data hub for feeding from another source, particularly if based on our vision you want to connect those across the organization. You want to try and make sure that your data is in one place that can be accessed by everything. The I part stands for the inputs, and this is obviously where the users start interacting with your model. So this is effectively their first element of Anaplan. And you might design your modules for inputs slightly differently than you would some of the other areas. So these should be user-friendly, they should be on dashboards, but you shouldn't really clutter those up with other pieces of the calculations because your model map's going to have arrows going backwards and forwards, whereas really this should be the kind of the left-hand side, if you like, or the top of your data flow. So try to build your module in a way that is more of a sole purpose. Just to sort of put out there, it doesn't matter how many modules you have from a performance point of view. The calculations are done on a line item basis. Your modules are just collections of line items. So you could have 10 modules containing 10 line items or one module containing 100 line items. That is not going to impact performance at all. So try and build your modules a bit more logically from an input point of view. The middle part of the word, and actually what's quite good is actually this is the glue of the system really, is this is all of the other pieces that you need within your model to hold it together. So this should be your time settings, this should be your mappings, your lookups, your attributes for your properties of your hierarchies. So all of these modules are effectively, they're not data modules, but they're the rest of the bits and pieces that you need in your model to pull it together. Because Anaplan is ultimately quite simplistic in terms of its structures, but you need some help in terms of joining those structures together. So that's what your system modules should really be. The calculations are obviously the heart of the model itself. That's where the work gets done, that's where the real clever stuff happens. And most of the time, these are not going to need to be user-facing. The users don't need to see these. So you don't need to make them as user-friendly. You don't potentially need the totals on. You don't necessarily need all the dimensions. You could combine the dimensions into numbered lists or combination dimensions to make them optimal. And they really have a purpose. And what we're trying to say is think about your model in terms of like structures and put all of your combinations of those structures in one place. So you know where you need to go to if you have a calculation that relates to your customer product hierarchy, or you know where you need to go to if you've got calculations that relate to employment costs. Because it's easier to maintain because they're all in one place, and it will make a lot more sense from your model map as well, because you'll have collections of modules that are purely for calculation. And then finally, the right-hand side or the bottom, depending on how you draw it, is the output. And again, this is likely to be, in most cases, more user-friendly. You may need to have the more dimensionality to allow that flexibility of reporting. Or it may actually be a sort of export or an output downstream to another system. But this, again, is kind of the end point. You shouldn't really have data flows coming out of this module that aren't going to another system. You shouldn't have this feeding into a calculation module, really, or feeding into an input module, because this should be the end. You can do it in Anaplan, and you can have those lines going backwards and forwards. But it makes it very difficult to understand what actually feeds what. So we're trying to encourage that kind of thought process before you build the models. And, DISCO is the acronym that you can use. And what's really good is we presented this at Las Vegas and in London. And you may have heard Frank talk about Rebecca Riley. Well, she's been an advocate. She's actually put on the apps, she's going to DISCO her model, which is a really good thing because it's beginning to, it was in the hackathon, people were talking about it. So for me, it's great because Anaplan is quite simple. It should be simple. We're making it too complicated. It doesn't need to be that complicated. So let's try not to do that. So really, if you look at a model map, and if you have a model map that looks like this, you don't have to worry about anything because that's a really simple model. But the principle is, the middle piece is inputs, calcs, and outputs. That's really what all models work with. They have inputs that go through some calculations and then they come out the other side. Your data should effectively be supporting that, so effectively being referenced everywhere, and try to have that referenced in all places. So try not to have your actuals going all the way through the system. Try to get them more of a kind of spider, if you like, so that it's always referenced, because that will encourage better performance in the way that the calculation engine works, because it can spread the calculations across multiple threads. And across the bottom, like we said, the glue, the system modules, again, reference everything once. Talked about that unnecessary calculations. We see too many times that people put the same formulas in different modules because they don't have one place for it. So you want to try and minimize the amount of calculations that happen, because if a calculation happens more than once, it's going to take longer. If your calculation happens once, it's quicker. So obviously we want to try and make our calculations and our models as fast as we can. So this was I brought this up because this was actually the first model that I built when I joined Anaplan 2 days after doing the training. So this was before I had understood anything about subsidiary views or anything about line item subsets or any of the fancy stuff that you could do. And I'd worked very much in my previous time before Anaplan on university student number planning. Now, you don't need to know how university student planning works, but from there you can see what's the inputs, what's the calculations, and what are the outputs, because you can see it flow. And I genuinely didn't touch that. I didn't deliberately make it look good for the presentation. It was just how I built. And so that's what I'm trying to sort of say. You should be able to have model maps that look something like this. Not obviously as small as that, but elements of it. So if you pick an output module, and you choose the show selection, you should be able to trace it nicely. And it should be, you can see the arrows are all flowing one way. They're not going backwards and forwards. As I say, calculation-wise, that doesn't matter, but understanding and logic, it's a lot easier to audit and to understand and to try and change things. So what we'll do now is look at a few of the tips that we found in doing this work, because we've been honest enough to say we didn't actually know the answers to some of the questions people were asking us about, is that better than this? We actually didn't know the answers to those. So we've gone back and actually gone through with the team in York and done some tests on certain things to say, okay, let's check some of these things to make models work better. And so these are the kind of first three that we came up with in terms of performance gains. And the good thing is you're not going to see any syntax in here that is complicated formulas, because, like I said, that's actually the wrong thing to do. So the first potentially quite surprising thing that you might find out is the order that you put your applies to does actually make a difference in how fast the calculations work when you get bigger models. Obviously, on small modules, it makes no difference, but on bigger modules, it can make a significant difference. And this is not about the pivots or the views you save. This is in the blueprint, the actual applies to that you see in the module or the line item blueprint. So let me explain why it makes a difference. And before we do that, let me just tell you a little bit briefly about how the calculation engine and computers kind of generally work in terms of multidimensional calculations. We've got an example here, a very simple one, of two modules dimensioned with products and customers. So a very simple way of doing price times volume equals sales. It's a very simple example, but the principle is the same. The first module has products as its first dimension and customers as the second dimension. The second module has it the other way around. It has customers first and products second. So grid-wise, structure-wise, they're exactly the same. Data points are the same, but dimensionally they're slightly different in that sense. And obviously we have a third one which times is one by the other. So what actually happens in the background, when it does the calculation, it kind of lays all these things out in a big long line to do the calculations. That's how computer power works. And it assigns an index. It doesn't actually look at the customer name or the product name. It assigns an index to the intersection. So in this case, you can see we've got 1 to 9 going top to bottom, left to right, and we've got the same 1 to 9 top to bottom, left to right, but you'll see that they're not actually aligned in sense of customer 2, product 2. It's got, they've got, that's the same, but customer 2, product 1 is actually a different index. So what happens when it does the calculation is it looks for these indexes. So the first one is easy because it's always 1, but the second one actually kind of goes down there. So it's now looking and said, okay, my index 2 for this part looks at index 4 for that part. And then the second one goes down there, and then the third one goes down there. And you imagine this over a list of 1,000 or 1,000. It's going up and down around the houses. It has no idea what's coming next. So it can't be optimized because it doesn't know what to do. So simply, if we turn them around and put them both the same, so now the indexes are absolutely the same in both dimensions. So that doesn't affect any data. No data's lost. All we've done is swap them around. Everything now is in a big long line. And it knows what's coming. So it pre-allocates all the memory stuff and just goes off in a Eurostar to England. And the interesting thing with that one is we found out that on 1,000 by 1,000 by 100, so 3 dimensions, if they're in the wrong order, it's 5 times slower. Now, 1,000 by 1,000 by 100 is not actually that big in terms of Anaplan terms. We have a lot bigger than that. So the interesting thing is all you do is put the calculations consistent and you will immediately get a speed advantage, which means you get a model calculating quicker. Now, you may say, well, why would I want to dimension it the wrong way around? It doesn't make sense. If I know that it's quicker, it's actually very easy to get them in the wrong order because the order that the applies to defaults to primarily uses the order that's in your general lists. So if you had the first module in our example, I had my products hierarchy above my customer hierarchy in my general lists, and then I create my module. So I drag the 2 across and I create my module. If I then reorganize my general lists and put it in alphabetical order, my customers may be above my products. So now I create my second module, and it will have put them the wrong way around without me realizing. But also, depending on what you drag into the pages and the rows and the line, and that grid that you create, that determines which order they go in as well. So it's really easy to get them mixed up without paying attention. But the even easier thing is it's absolutely simple to put it right. You click on the ellipses, either in the module itself or in the blueprint view. It will display the order that's in the general lists, and you click OK. That's it. It's switched it round, no rollbacks, just done, which means now you have a consistency. So I would encourage you to go down your blueprint, look and see if you do have calculations that cross over, and even if you can't work out whether they are being used A times B, just put them in the same order because it makes sense, it's logical. Now the thing to watch for is subsets will always go at the end because they always do. So depending on what you're doing, you might have to manually change it. And what not a lot of people know is you can actually double-click directly in that applies to and manually change the order. You can change the dimensionality in there. You don't have to use the dialog box. So that one is a really simple thing to do when you get back. You just check it, click, 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 done. It may not make a difference, but it might. And it's worth going. It's worth a 2-minute review of your models if you're going to do that. So the second tip, and as I said at the outset, we're making it too complicated. So we want you to break things up. I haven't got time to go through some of the formulas that we see out in the field, but suffice it to say they are pages and pages and pages of Word. Literally 30, 40, thousands of expressions. I think the record is 1,500 expressions in one line item formula. It's just ridiculous. You know. So what we don't want you to do is to put everything in one place. We don't want you to use combinations of functions and all those kind of things and nested if statements and hundreds of... Because they don't perform very well, and I'll tell you why in a second. They're also impossible to edit and understand. Because you look at this thing and immediately you just go, ugh. You know, you won't even try. And it's the same thing we see with spreadsheet formulas. You see those horrible spreadsheet formulas, you give up, don't you? It's like, I can't, it falls off the screen, you know. So let me explain why it's a problem. So this is based on a real example, and the real example had 57 different expressions feeding from 8 different modules. But to represent that here, let's just assume we've got one line item that's got 5 individual line items feeding from 5 different places. The principle is the same. When I change something in product sales, the calculation, there's nothing in that total profit number that's telling me what service sales are, what OPEX is, or what COGS is, because it's not stored anywhere. So it doesn't know what that number was. Even if that number hasn't changed, it has to go and get it again, because it's got no way of knowing. It's got to calculate everything together. So when you put everything together, every time any component changes, all of the other ones have to be recalculated. So when you've got some big structures in here, and that price one might be quite heavy, or the OPEX one might be a really long, complicated formula, even if it's not changing, it's having to do work. So as an extreme example, and yet you don't want to be putting a single formula in every single line item because your models would be huge, but in principle, look for the biggest ones or just try and break them up into sections. So in the example I gave there, I broke them out into each 10 line items I put in, or formulas I put into one line item. So all the stuff coming from the first module was in one line item, all the stuff, which meant if you had to make an edit to it, you just added it on the bottom of that one, not to the bottom of the formula. Because that example I gave you, the first 3 or 4 rows were from module 1, then there was some from 2, then there was another one from 1, then there was some from 4, then there was some from 3, and then a bit more from 1. They just chucked it on the bottom every time they needed another one, which was impossible to... It took me half a day to work out what the formula was actually doing. So here we break it up, and we say, okay, product sales, they all link individually. So now what happens when I change product sales is it only has to do the product sales and the total. It doesn't have to touch the others because it has got the result already calculated. So making it more logical, making it more maintainable, making it more sustainable gets you better performance. You don't have to try to get better performance, it just works for you. You're not changing your formula structure, you're just breaking it into sections. And that even applies if you have a very simple formula that is this plus this plus this plus this plus this plus this. Once it goes past about 10, split it into 2 because it will be quicker. Because not everything's changing all of the time. Same thing would happen with COGS. Only the relevant ones are changing. The other thing that, I'm inherently lazy in the sense of I don't want to do more work than I need to. I'm sure you don't. And the calculation engine is exactly the same. Why make it calculate things when it doesn't have to? So the way we can do that, and we put it avoiding traffic or just taking the shortcut, whatever it might be, let's try and get the calculation to stop as soon as it needs to stop. So what we're saying here is think about what happens the most often. So if you look at that structure, we may have a formula that does something like this. It may say, okay, I've got some winter promotions, and when there's a winter promotion, I do this. When it's a summer one, I do this. Otherwise, if there isn't anything, I don't do anything at all. And the most common occurrence of things happening in that grid is actually nothing to do with promotions. The nothing happens the most. There are more times in more months there that nothing happens than anything else. So it's more efficient to put the formula to say, let's put the nothing at the beginning. And then we check for the other ones. And in this case, that's still not particularly great because the winter one is more than the summer one. So what we can really do, the timings here are just representative. We can actually make it more optimal. Based on the previous example, we put another line in that does the calculation for the knots and then check that first. So if there's nothing, we do naught. Because then it stops. The calculation goes, I don't have to do any more because I've done it. So things like history periods, most of the time we'll have a formula that says something like, if it's a history period, then do something, otherwise do something else. But most of our models have more future periods than history periods. So do the check for the future periods first and then do the history ones later. If it's a kind of, I don't quite sure which one it's going to be, okay, doesn't matter. But a lot of cases we find that there'll be one condition that is way more common than the other ones. So put that one first. And in this case, we have seen some significant savings. We're talking tens of seconds on some calculations. It depends on what you're looking at, obviously. So put the most common expression first. And it is difficult when you first do this, but having done it myself, you get yourself into a habit of you write the expression and then you go, actually, I need to turn it round. Because you just work out, actually, yeah, that is the other way. So, you will get used to changing it if you think about that quite heavily. So break it up and also look at the sections. When you're doing this, break it up. But the other examples we've got, which are quite good ones, is something like find item, which is actually quite a heavy calculation. It has to traverse the whole of a list to find a text item. And we see lots of data calculations going on where actually the data it's trying to find is actually blank. So what's it going to find after it traverses this 2 million list? Nothing, because there's nothing to look for. So why look for it? Tell it if it's blank, don't do anything. And again, this makes a huge difference. We're actually, on the back of this, talking to the product team to try and build this in as an automatic check, because some other functions we have in Anaplan have that if it's blank, it doesn't do anything. But find item is not one of those. And find item is quite a heavy calculation. So try and look at which is the most common one and get it to do that only. One of the questions that we've had off this in the previous one was, what if I've only got maybe 2 or 3% of blanks? Well, it might not make a difference, but it's still just good practice to do it because, the check is actually very small. The actual time to check it is tiny. So it's still worth looking at doing that. And a couple of other quick examples. The lag or the offset or any of those where you're moving data, so the diagonal calculations as I like to call it. If you ask me to take no steps to the right, I haven't got anywhere. So don't ask me to take no steps to the right. It's silly, because I'm going to stay here. So if you find that one of your parameters you're using to lag or offset is naught, don't make it do a lag of naught, because it's just extra stuff to do nothing. So just use the number. So if you say if the lag is naught or the parameter is naught, then use the number, otherwise lag it. Again, just trying to let it do less work than it needs to. And my final pet hate one, you don't need to do that. It's 23 extra characters to type in your model. And I know that you'll have that all over the place, and there'll be thousands of these because I've found them all over the place. It's the same, people think that Excel, you have to do that. You don't. Excel, you don't either. It can only ever be true or false, so you don't have to tell it to be true or false. And it makes your formulas smaller. It makes them easier to understand. It makes them shorter. Everything becomes easier because actually that's just more logical. So I told you I don't like doing more than I need to do. Now, in itself, doing one of those is going to make very little difference. But the actual checking process itself of doing that, if you've got 1,000 of those in your model, that might make the difference of a user going, it feels a bit slow versus it's okay. If in total that makes half a second, that's actually quite a long time as a user hitting a number and waiting. It's that versus that. So all of these things we've said up to now, each of those in turn could make a little bit of a difference. And you add them together and you get 2-3 seconds of savings. So on that topic of let's try not to calculate when we don't have to, let me just talk about how Anaplan works from a calculation point of view and what dimensionality and what calculations actually go on. So again, simple example, 4 region levels, 3 product levels, and 2 channel levels. So, again, relatively simple, but the principle applies the same. There are 24 blocks of calculations in there. So discounting time inversions, this is how Anaplan calculates. And this is how it works so fast, because it squashes all these into individual components and says, what's the block of calculation? So when I change a number, it knows which other blocks to change. It doesn't have to change everything. So the biggest block is always the bottom level. So here it's the lowest level of all those hierarchies. And that always will be the biggest one. Now, if you turn your summary options in your line item off, that's all it calculates. If you turn it on, it does all of those. Because every time you change a number, it does all of that, which is the default for every number line item you add. But in a lot of cases, you don't need all of these because you just don't need the calculations. I may only want that one, but I'm doing all of the other 22 summaries just for that. Or I might only want city or by all products. So what we're now saying is when you create a line item, and again, this comes back to Disco, particularly if it's a calculation module, turn the summaries off by default. So when you start, turn it off, because it is a lot easier to turn it on again if you need it than to turn it off after you've built your models, because you have no idea where it's being used and it's impossible. You type a number in, you've got to start exporting out your final report and changing a number and going, has anything changed somewhere in there? Maybe, But we're actually looking at the product team to say, can we make it off by default? Because actually, most of the time, you have detailed calculations that go to detailed calculations that go to detailed calculations that go to something at the top. Those ones in the middle do not need any totals. If it's not a user-facing module, turn them off. We have saved gigabytes, gigabytes and gigabytes. We took a 12 gigabyte model down to 4 just by turning some summaries off on 2 modules, particularly if you've got big hierarchies. This was a 4 by 3 by 2. We know you've got product hierarchies that are 6, 7 levels. There's a lot of stuff happening in there that you don't need, because most of the time those hierarchies are actually just for navigation or for the way the business structure is. You don't really need them from a calculation point of view. So that can make a massive difference. The other thing that we see, and we talk about this repetition, is if you look at that formula in there, you can see it's in this module 3 times. So what it's doing there is it's doing a check for history periods. But not only is it 3 times in that module, it's also calculating that by the organization hierarchy, the hour scale, so that's 1 to 12 at least, maybe even 24, by the type of call center, by day. Now, that calculation changes every week. So because the calculation is embedded in that line item, it's doing it for all of those dimensions. If you put that expression in a separate line item and left the applies to as it is, you would see tick boxes all over the place. Whereas actually, that calculation doesn't need to be done like that. But because it's in one place, it has to. Back to that previous example, it has to work it all out. So if you're doing anything to do with product hierarchies or customer hierarchies, and you put that expression directly in the formula, you're over-calculating. And just to show you how much you're over-calculating, that's a time management module with exactly the same expression, and you put the same formula in it, and you reference that in the other module. That's 105 cells. Those 3 are 850,000. So it's doing 843,000 more calculations than it needs to. And that's just one module, and you can see if you look closely on there are similar structures repeated in the other line items, and I know for a fact that formula is in about 3 or 4 different modules 4 or 5 times as well. So going back, don't want to labour the point, but go back to the Disco one, your calculations should be done once and referenced many times. That calculation changes when I change my time period. That's it. I don't want to calculate that every time I change any other number. Why would I? So think about the calculations, and the takeaway here is look at the native expression that's in there and look at the applies to of that line item. If it doesn't match, put it somewhere else. Put it in a module where the dimension is the right dimension. And if you have to break that formula up into 3 or 4 pieces, that's the right thing to do because you're then going to get a massive performance gain. So, in terms of what I want you to do when you go back to your offices, have a look at this. This is not actually that difficult to do retrospectively because you can create 2 modules, you can swap dimensions around, you can move the line items around, but certainly as you start to build new models, don't just dive in and start tapping on the keyboards. Even in things like the hackathon, we talked to them about Disco and we said, you just have to take that step back and try and draw out on a piece of paper or on Visio or something, just how the data flows together. So really think about that because you will get massive benefits across all of those areas. Dead easy one when you get back 2 minutes before you go home, just check your dimension order, make sure they're the same. Be consistent. How do you deal with your hierarchy? How do you talk about your business? Put that first if that's how you think about it. We talk about customer and product, okay? That's how I talk about it. Let's make sure everywhere I have customer first and then product second. Just be logical. It's easier for people to understand. Look at these big formulas. Dump it to Excel. Do a count. Anything that's more than about 200, take it out. Break it up. We want to try and get some of this stuff in the product that tells you when you've gone more. But if you think about your formula bar, if you go off the bottom of that formula bar, and I don't mean drag it across the other side and make it bigger, if you go off the bottom of there, it's too big. If you have to edit it in Excel, it's too big. And we all know people do it because we've seen formulas that have to be created by people who've done it in Excel. Why would you have a formula that says, comma 10 plus 10 plus 10 minus 12? Why would that be in a formula? Because someone's dumped it in Excel to create it and copied it back. Nonsense. Absolute nonsense. If you can't explain it in one sentence simply to somebody, it's too big. Anaplan's not complicated. Let's not make it complicated. Think about how to make it stop calculating when it doesn't need to. So have a think about, look at some of these formulas. Look at the order. Again, it's an easy switch around. And again, it's better to do something like if future periods rather than if not history periods, because that's an extra check it doesn't have to do. Yeah? Think about the true condition as opposed to a not condition is faster, just because it's a bit less to check. Again, marginally, but it all helps. And look at these summaries. Have a look at the formulas and particularly look for your detail to detail, and also look at your biggest modules with the biggest hierarchies in. A 3 million list item with a subtotal on the bottom, you're going to save one of the 3 million. It's not going to make a difference. A 7-level hierarchy, there's a lot of totals in there. A lot of time totals. Do you need all the time totals? Do you need quarter to date, year to date, total? Maybe not. Have a look at those when you go back and see. If in doubt, turn them off and look at the answer. Did it change? If it didn't, then you're okay. If it does, then you've got to work. Because you can manage those using a sum formula. Yes, that's slower than a native Anaplan sum up, absolutely, but not if you only want one of those 23 blocks. One of those 23 blocks using a sum is much faster than all 23. So have a look at those. And if you want a bit of help, we've actually, as part of the organisation, got some accelerator packages that we can help you with. So reach out to your customer success business partners or your partner success managers, because we can come in and help you with some of these things. If you need a bit of help with the design, if you're not sure you can do it yourself, or you want some help around things like data hubs or ALM, all of those areas, we want to make sure that you're having the best experience with the Anaplan models. And if you're not sure you're comfortable doing it yourself, then reach out because we can help you. So the other thing I would say is look on community, because I'm actually publishing, all of these 3 are actually articles on community. The easiest thing to find it is through the left-hand panel, but if you actually type in Disco, it comes up. Because it's brilliant. But look at shared best practices. We're going to look to try and do one of these every month, a little tip every month. Just keep watching that. Keep subscribing to that channel because they're all the time. And if you have any queries about, I need to know if that's better than that, put it on community because we are answering these questions and we are checking. So thank you very much.
Thank you, David. Thank you very much. I love the disco thing.
Sorry?
I love the disco concept.
Disco.
Yeah. Any question? Please raise your hand.
Yes. Thank you for this, David. One question about lookups. We can put some, for instance, if I wish to look up across a property which is in a list. Is it quicker to do lookup list dot a property, or to have the lookup as a line item in a module, and to perform lookup dot module dot a line item? Do you have any idea of what is the quickest?
In that case, it makes no difference whatsoever. List.property or module.lineItem are exactly the same. However, I would always advocate using modules instead of lists, because the calculation time is no different, but you can't turn summaries off on your list properties. You can't do ratio calculations. You can't filter them. You also doesn't show up in the model map, so you've got no idea where they're being used. I know the references by now on the latest release, or the couple of releases ago, now helps, but you also can't move them around. So what we're saying is those system modules we talked about, create one of those for your big hierarchies and put all the properties in there. So you know that that's the logical place to go, because it's easier to work with modules that have attributes and properties in than it is with list properties. You know, you can't control, if you publish that information onto a dashboard, you can't control any of the columns. You can't filter, you can't hide, you can't do any of that. So using a module is better. We're actually looking at whether we can generate some of these things automatically, because that is really what we want to do. We shouldn't see parent, 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 parent everywhere, because we should have module line items that have them. But pure performance, and again, it doesn't make any difference from a it is in the cell count in a way. It's not in the module cell count, but it does count. It's a two-dimensional module. So list.property, line item, of module, same thing.
Other question, maybe?
I can answer in French if they want. You can translate.
Okay, so it's time to close the session. Thank you very much. Thank you, David. Thank you to everybody.